This video is an exercise 1 of the Conservation Applications of LiDAR, Basics of Using LiDAR Data. This material is organized into 3 different sections, one talking about how and where to get Minnesota LiDAR data, the next briefly about navigating within the various different resources, and the last talking about file formats. Now, if you're viewing this video, it's important that you access the PDF that I'm displaying on the screen. And that PDF could be found at this location, and that when you're at that location, you would want to be looking at the information about LiDAR and bringing up the PDF that I'm showing you, which is under the Education and Training, Workshop and Training Materials, and it's here within the exercises, accessing. And this is important information for you from the MinGeo website, and that's what I'll be discussing in this handout exercise. Now, there's other information that's available at the Minnesota DNR at this link, and that you'll want to continue to check the MinGeo site, because they're on a regular basis updating the information about the LiDAR. And there's also information about other projects related to LiDAR use in Minnesota. Now, in order to access the information and use the information from the Minnesota MinGeo or the DNR site, you would need to use a FTP client. And the FTP client that we recommend, it's free, called FileZilla. And you could access it from this link. And you would click on the link, download for the operating system you're working on, and you would see a product called FileZilla. And there's quite a bit of information available about FileZilla. And the important thing is that when you do access the information, it'll look like this on FileZilla, and it's very similar to Windows Explorer, where you have one panel on one side that is your computer, and the other panel on the other side is the remote computer. And you'd be selecting information from the one side and dragging it to yours, so you'd be transferring. And it's important you do this instead of using Internet Explorer or Mozilla Firefox or Opera or Safari, any of the browsers to transfer data, because this is a much more efficient way to do it. These are very, very large files, and you need to transfer the data in this fashion. Now, the other thing is that at the location of the information that on the reference on the PDF, you'll want to take a look at the README file, and that README file is at the LiDAR in the LiDAR subdirectory, and there's a README file as well as a WatchMe. And that WatchMe is a very useful little video which talks about the Minnesota LiDAR data and how you would access it. Now, the Minnesota LiDAR data is organized in a very useful way for the huge file size. And much of the information is provided is not just the raw data, but it's processed data that the Minnesota DNR has worked with outside vendors to create for you. The most important would be organized, and the state is broken up obviously into counties, and each county has information that is aggregated for that county, where they've created a county mosaic of information, which is very large. And there's also a geodatabase which breaks up that county into smaller pieces. And the pieces that the breakup of the the county information is broken them up into the USGS quarter quad or USGS quads 1 to 24 series, and each of those are then further broken up into 16 small tiles. And within this subdirectory, for your county, you have the general information here. But then if you go to the Geodatabase subdirectory, you would see the Geodatabase for one of the pieces of the tiles within that topo, within that 1 to 24 series. So there's a lot of information, and it's important you learn how to access it and bring it down, and you might consider using the similar structure that's outlined on the MinGeo, where they're organizing things into geodatabases, because the geodatabase is a very efficient way of organizing this information. Now, there's also information about the raw data, and the raw data is organized in an LAS file, and that LAS file is compressed for transfer. So there's a subdirectory that tells you about the information for each of the file, the LAS file, how many points per square meter per meter, and so on. There's a lot of real detailed information about the points that have been used to build the geodatabases. And there's also the actual compressed files themselves, the LAZ, the compressed point cloud file. Now these point cloud files I'll talk about in a second, but let me speak briefly about the rest of the subdirectories that are in the MinGeo for your particular county. There's an example subdirectory that you might want to take a look at, some samples, some products. There's some previous projects that have been where LiDAR has been used across the state. But probably the most important for you is the tile index, and that's where it shows the details of these small little tiles, the 16 that are within the USGS 1 to 24 quadrangle, and that are then and then all those quadrangles that make up a particular county. So this index is very important. So you have to understand the numbering scheme so that you're able to find the data you want. There's also a series of tools. Perhaps the most valuable is the LAS tools. These are tools that are created by a very LAS tools were created by Martin Eisenberg. Dr. Eisenberg has done a lot of work both throughout the world as well as with the Minnesota DNR about LiDAR data, and has created a series of tools which allow you to work with the raw data very easily. Most of our discussion will be working with the aggregate data or the derived data that the Minnesota DNR has produced using ArcGIS. But this is the location for working with Dr. Eisenberg's tools, LAS tools. There's also some other utilities and toolboxes that have been created to work with LiDAR data. Then within the handout here, we're having a recap of the FileZilla, where you're actually transferring data, and you would transfer the data by selecting it on the right and moving it over to the left, which is on your computer. Now, what we're suggesting in this to get ready for exercise 2 is that you actually go in and select 26, 24, 63 within FileZilla, and you would move that. So I'm going to pick a LiDAR. Within LiDAR, I would select within LiDAR the county, and in this case I'm going to select Nicollet County, and I'm going to be selecting that the 26, 24, 63, the 426, and so I'm selecting the Geodatabase, and I'm selecting 24, 26, 63. Oops. So I've selected and then I'm going to move that over to the subdirectory that I'd created on my side over in and within basics, within raw data, and I'll just drag that over to that proper subdirectory. And now I've already got it there, so I'm not going to transfer it, but you'll begin the transfer, and it takes quite a while depending on your data transfer. Now, while this is being transferred, we'll talk about the information that you're preparing for the exercise 2 and bringing down. Now, we're bringing down a geodatabase, and within that geodatabase, there's some information that's been prepared for you. The one piece that's very, very useful is the DEM, or the digital elevation model. And that's a raster surface, a checkerboard, which describes in each cell, and each cell would be 1 meter, there's several different series. The 1 meter and the 3 meter are available, and that in each cell is the elevation above the reference surface. Now there's all this is stored within this geodatabase, which is a data structure that Esri has created several years ago to try and bring together all the important pieces that are needed to display geospatial information. And this is a file geodatabase that's being used in our LiDAR world rather than the personal geodatabase, which you could find within ArcGIS. The personal deals with a smaller file size, and we have to use the file geodatabase because of the large size of the file. So there's the file geodatabase, a critical component, the raster, and then there's the feature data within that geodatabase, in addition to the raster, where contours have been derived from this elevation model, and break lines and bare earth and buildings and some other information that came from the raw data that's provided to you and been processed for your use. And there's also the raw data. And though probably most of your work would be using the DEM or the feature data, there is the raw data if you're interested in working with it. And the raw data takes each laser point that has been shot from the plane down to the ground and classifies it based on its intensity of the return and then the number of the return, and that number and intensity is used by the vendor to classify that into bare ground, vegetation, buildings, water, and so on. And that is all available to you. It's available as an LAZ, and you will have to unzip it, if you will, uncompress it to become an LAS and do some additional processing steps to get at it. We'll show you that in later exercises. The last piece that is available in the geodatabase is the terrain database, and that's another ArcGIS data structure which brings together both the bare ground data as well as the elevation data and stores it in a fashion that's a little more efficient than the raster. The triangulated irregular network, or TIN, is a hybrid structure where it has many of the efficiencies of a vector layer, but it represents the continuous surface accurately. And from the TIN, which is the most efficient to store, you could actually create the DEM. So that ArcGIS, the Esri vendor, is suggesting that this be the basis of our terrain modeling, that we would store TINs that would within a terrain model, and we'd store contours, and we'd store some bare ground information, and that information would be used to create as needed the much larger raster data structure. There could also be break lines and some other information available in the TIN. Now, there are some additional resources that you might want to take a look at. I mentioned the LAS tools, that being sort of the primary if you're going beyond ArcGIS, but there's others within the DNR where they've created a number of toolboxes which might help you when you're working with this LiDAR data. This completes this first lab, and we'll now move to the second lab.